going to go over comparing functions. So what we have here, we have two different functions represented in two different ways. We have a graph and we have a table. And whenever we compare them, we want to see which one has the greatest rate of change. And by rate of change, we mean the slope. So in the equation y equals mx plus b, we're talking about the m. So to find our m for a graph, we know that we want to use the formula rise over run. So I need to pick out 2 points, and we always work from left to right. So I'm going to use this point and this point. And we want to see, do we go up or down, and then how many do we go to the right. So to get from my point on the left to the point on the right, we have to rise. So we go up 2 spaces, and then we go over 1. So my rise over run is 2 over 1, which means my m for function A is 2. Then on function B, we want to do the exact same thing. But since it is in a table, we can't do rise over run, so we're not able to count the actual spaces. So for a table, we use the formula change of y over change of x. So what we're looking at is what are my y values doing divided by what are my x values doing. So I see my y values, 0, 6, 12, and 18. Those are going up by 6. Over my x values, 0, 2, 4, and 6, they're going up by 2. So then I can reduce my fraction. 6 over 2, we know is 3. And now I can compare the two functions as a whole. So function B has the greater rate of change, and now you know more.
Hey guys, it's Mr. Gossam here. We are comparing functions today. So let's look at this problem and answer these 3 questions about these 2 pandas. So we have Mochi. He's a panda, and this is represented the weight in weeks of Mochi, and this is Kappa, and this is a graph based on the weight over weeks. So we're comparing 2 different styles of information given. So which panda was heavier when they were born? So at 0 weeks, when they were just born. So on this one, we're looking at 0 weeks, Mochi was 1 pound, and then over here at 0 weeks, because this is weeks, in pound, this is 2. So this is 2 pounds. So Kappa weighs 2, Mochi weighed 1. So who weighed more? Kappa. So we're gonna put Kappa. Okay. Which panda is growing faster? So we need to find the slope. So we need to find the slope of each. I'm gonna find the slope of the line first because I feel like that's easier. So if we look at the rise over run, okay, we go up 2, and then we go up just a half here. So if you're thinking about it, this breaks down to 1, 2, 3, 4, 5. So if you want to, we can go up 1, 2, 3 over 1. So this is 3 over 1. So 3 pounds per week. 3 pounds in 1 week. Okay. So over here, in 1 week, you should be able to see in 1 week how many pounds were gained. Well, in this case, from 1 to 5, they gained 4 pounds in 1 week. Okay, so 4 pounds in 1 week. So right now you can compare the two. Which panda is growing faster? This is 4 pounds a week, so Mochi is growing faster than the 3 pounds a week, which is Kappa. And then the last one, which panda will weigh more at 5 weeks? Well, it's a projection. So if we're looking at what we're doing, so right now we know we could do this in 2 different ways. We could come up with the equation and then plug in 5, and we could figure that way out, which we could do that, or you could just continue the pattern and figure it out that way. And in this case, I see that we're already at 3, so I'm just gonna go ahead and finish the pattern. So at 4 and 5, I'm gonna extend that. Okay, so if we're going plus 4 every time, 13 plus 4 is 17, and then 17 plus 4 is 21. So which panda will weigh more at 5 weeks? Mochi will weigh 21 pounds. So then let's see at 5 weeks over here how much Kappa is going to weigh. So at 5 weeks, let's just continue the pattern. We know that it's 3 per week. So if we go up 1, 2, 3 over 1, we can see that it's 16, 17. So it's going to only be 17 pounds. Okay, so 21 versus the 17 pounds in 5 weeks. So which one's going to weigh more? It'll be Mochi. So there's a variety of ways that you can learn how to do all of these. You can get the equations. You can plug that in. Miss Gardner and Mr. Hart are going to be able to teach you those ways. So this is just the way that you recognize a pattern and you can extend the pattern. So that's what I'm teaching you, but the other two teachers can teach you the other way. So, and now you know more.
Hey guys, it's Miss Garner. Today we're going to go over distance versus time graphs and how to interpret them, specifically the slope. So we'll start with 1A. A child runs at a constant speed for 40 seconds before stopping. So first I'm going to look at my 4 graphs. I see that all of them have distance for the y-axis and time for the x. So I want a graph that has a constant speed until I get to 40 seconds, where it should then stop. So I see in this graph, I have a constant speed up until 40 seconds. So this one is a possibility. This graph, I have a constant speed all the way through it, through 60, so I know it's not going to be that graph. This graph, the speed changes before you get to 40, so it can't be that graph. And then this last graph, I once again have a constant speed until 40, and then when it levels out again. So this is also a possibility. So what I would do now is go back there and says a child runs. I'm going to think about a child running. Right here, this says in 40 seconds, you're only going to be 50 meters away, versus in this case, in 40 seconds, you're going to be 75 meters away. So I would probably pick this first graph to be 1A, considering a child running will probably be faster. So your slope is going to be steeper. You're covering more ground in less time. Now we'll go ahead, get our 3 options back up there. We're going to look at 1B. A panda moves slowly at a constant speed for 40 seconds before stopping. This is the exact same situation. In this case, a panda is moving slowly. So we already know this last graph here has a constant speed until 40, where it then stops. And by stops, we mean our distance isn't getting any greater. If your distance isn't getting greater, you're not moving forward, so you've come to a stop. So we know this last graph has to be 1B. Option C says a cheetah stalks his prey, moving slowly, stopping occasionally. So once again, if we want a line to stop, it's going to be horizontal because your distance is not increasing. So I see right here, I've got a slope, and then it goes horizontal, slope, horizontal, and it keeps doing that. This represents the cheetah slowly walking, and then it comes to a stop, so the distance doesn't get any greater. Slowly walking comes to a stop. So this is going to be 1C, which means my last option should be my last one. So let's double check. A rabbit runs away from a farmer, not stopping for anything. So we know this has to be 1D, but it makes sense because if it doesn't stop for anything, the rabbit runs, we assume it's going at a constant pace. It should just be a straight line all the way through your graph. It should be no jags or anything. And then finally, it's running, so it's going to be a lot faster than any of these other scenarios. And as we see, it's a steeper line here. So the steeper line represents a faster speed. So those are our 4 options, and that's how to interpret the slope in a time versus distance graph. And now you know more.